Hello there. It's me again, Dr. Zero. I hope you remember me from the Zero Breakdowns video, and I hope you've reduced your breakdowns to zero, too. I'm the one who's here to guide you through a lot of ideas for improving production systems in the factory. Of course, work is no laughing matter, but that doesn't mean that we have to be poker-faced all the time we're trying to improve things. Less mess, less stress. Anyway, I like to think about improvements by first of all looking at problems in daily life and seeing what we can learn from them. For example, setting up a machine in the factory is like a puzzle, and I'm having a frustrating time trying to puzzle out this puzzle. Will I ever finish, I ask myself. I'm trying very hard, and the puzzle is very trying. But I'm not going to get upset by this setup. But what does this have to do with work in the factory, you may well ask? Well, setup operations can be puzzling, and they're all to do with putting things in order, too. The only difference is that this is only a game, and my time is not money. But if this was a setup operation in the factory, what would happen then? There's a real problem if you don't know when you're going to be able to start the next production operation, because you have to wait for setup. Right? So, what we all want is zero setup losses, no waste of time, no waste of effort, no endless repetition, and that kind of thing. And that's what this video is zeroing in on.
The vital work of operators is to produce fine quality products through efficient use of equipment. But if the work process is constantly delayed as a result of setup operations, the production volume goes down and the cost per product goes up. The operating ratio of equipment equals operation time divided by total working hours multiplied by 100. The result clearly shows what percentage of our working life is spent productively and how much is basically unproductive. Reduced stoppages leads to longer actual production time and a far better operating ratio. For example, with equipment that is capable of producing 100 items per hour, if 1 hour is lost for setup operations and these have to be done twice during one 8-hour shift, then the total operating time will only be 6 hours and the number of items produced will be 600. The operating ratio is only 75%. By cutting the setup operation time to just 15 minutes each time, we can increase total operating time to 7.5 hours, and 750 items will be produced, giving us an operating ratio of 93.75%. In other words, there will be a 25% increase in productivity. Let's see how this works in practice from an operator's point of view. Our actual working time is divided into operating time, preparation time, incidental tasks, and non-productive work time. Preparation time includes necessary preparations both before and after the production process. Incidental tasks includes measurements, checking with manuals and plans, and so on. Non-productive work time includes any activities outside actual production activities, such as meetings and clerical matters. If the non-productive time spent each day is more or less fixed, then simply by reducing the time for incidental tasks and preparation time, operators can increase their operating time, in effect lowering the cost per item.
Get the idea? Losses in setup operations are naturally a problem for the operators. What I think we should do next is take a look at what we mean by setup losses from 4 different viewpoints. 1. Work procedures. 2. Organization of setup operations. 3. Accuracy of equipment, jigs and tools. And 4. The work environment.
Most factories use a variety of jigs and tools during setup operations. Although according to the basic rules of 5S, these should all be kept in a centralized position, three things often occur. Items are not in the right place. It's not clear who is using them. And some items are damaged or broken. If you have any of these problems, then time is wasted looking for the necessary items and you may not be able to use them when you do find them. The point is that jigs and tools needed for setup operations should always be kept and used in such a way that the operator who needs them never has to move around searching for them. In other words, no moving and no searching. To ensure this, there are three important questions you can ask yourself. Are your jigs and tools suitable for the job, and is there a sufficient quantity of them? Are they stored in an accessible place and clearly marked? And are they available for immediate use? On the other hand, even if all the preparation is done well, unless the work procedure for setup operations is correct, there will be little improvement in efficiency. Product quality and production time will vary if each operator sticks to different work procedures. Each piece of equipment basically has its own work procedure. It is very useful to draw up a standardization checklist that everyone can understand easily. It should be readily accessible and everyone should be trained to stick to the right operation method rather than use their own individual way.
5, 4, 3, 2, 1, action! Oh, good, good. Hold it right there. Don't move. Good. Oh. Battery low. Is your battery okay? Did I charge up that other battery? Oh no! Dead! Failed in my setup again. It's reviving! Which reminds me of what I want to say next. There are two stages of setup. External setup, and you guessed it, internal setup. Internal setup means setup operations which can only be done by stopping the equipment, like stopping to change the battery. And in the factory, that means breaks in production, and that causes losses. On the other hand, external setup can be done while the equipment is still working. For example, getting the battery charged in advance. In the factory, production can continue while this is going on, and the result? 0 losses for that phase of the setup. But not everything we treat as internal setup necessarily has to be internal. We should have a little think about whether some internal setup operations could in fact be converted into external setup operations. You can either save or waste time with setup operations. For example, look at the size of this bolt. Enormous. Take me a long time to get the nut off. Who designed this? A time waster, no doubt. This is only one. Just think if you had 4. But we're always coming across this type of thing in the factory. At last. But this, on the other hand, right size. No waste of time, no waste of energy.
Here's an example of improvement of assembly operations. In this factory, workpieces used to be fixed on a pallet one at a time for drilling and processing. A lot of time was wasted during workpiece exchange. The improvement implemented here was to fix two workpieces on the pallet at the same time and control processing with numerical control. The time spent removing and replacing pallets was greatly reduced through careful thinking and the use of automated equipment. You can also reduce setup time by giving careful thought to the shape and condition of the workpieces. This lathe processes the front face and edge of flywheels. Before improvement, a chuck was used like this, so it was impossible to process the front face and the edge simultaneously. The solution was to add holes to the wheels so that chucks could be fixed from the front. Now both the setup operation time and the processing time have been significantly reduced. This rethinking of shape and condition of workpieces can be applied widely to reduce the number of setup operations and the number of procedures involved. It's true to say that a large part of setup operation time consists of adjustment operations. Adjustment involves the repetition of corrections until you can find the optimum and stable conditions for production. This requires trial processing and checking. So it's not just a matter of time. It also depends a great deal on the technical skill of the operator. Any mistakes, and you may have to repeat the process. What we have to ask is whether it's possible to get rid of the adjustment operations and get machines to do the work for us. In other words, convert manual tasks into automated tasks. Here's an example. This equipment is used to drill holes in spindles. It used to be necessary to drill from both ends to complete the hole, involving adjustment time between the two drilling operations. After some thought, a way was found to drill the hole in one operation using a gun drill. You can also reduce adjustment time by improving these 3 points: fixing the datum level, measurement methods, and accuracy of equipment, jigs and tools.
I've got a great graph here to show you. It looks just like my bathtub, and in fact, that's what it's called, a bathtub curve. It shows the length of time equipment has been used and the rate of breakdowns.
When equipment is first used, problems often occur, but these are usually dealt with by the manufacturer. Generally speaking, once equipment has passed its useful lifespan, it starts to suffer from fatigue and wear and tear, and there is an increase in the number of failures and breakdowns. Operators normally attempt to prolong the equipment life through careful maintenance and preventive measures. This means maintaining the required accuracy through protecting equipment from deterioration and dealing with any minor defects which could cause problems. In particular, with regard to setup operations, the accuracy of jigs and tools will have a considerable effect on working hours. It's essential to maintain accuracy at all times. Jigs and tools must be cleaned after each use and all the important parts checked to make sure they are operating with complete accuracy. Periodic checking is also very important. The checking cycle has to be determined according to the type of jigs and tools in use. To consolidate a periodic checking timetable, you need to answer these 4 questions. When are the checking dates? Who is responsible for checking? Where requires checking? What is the required level of accuracy? However, even if the accuracy of jigs and tools is properly maintained in this way, you still may not be able to get the required accuracy because of the assembly methods employed during setup operations. For example, let's think about a case where assembly of 5 10mm jigs produces a 50mm total height. If the tolerance for the total height is 1/100th of a millimetre, is it really possible to obtain that accuracy when the tolerance of each 10mm jig is also 1/100th of a millimetre? This graph shows the range of variations in jig heights. Even when the accuracy of all the jigs used is within the permitted standard deviation, if they all deviate in one direction only, either plus or minus, this results in excessive deviation from the required 50mm height, as much as 5 times the specified tolerance. As far as possible, it is better to prepare a properly adjusted stack of jigs or a stack with fewer components, rather than having to put many individual jigs together each time. This is the kind of improvement which not only reduces adjustment time, but also removes the point of aberration right from the start. As you can see, through proper maintenance of accuracy at all times, you can greatly improve efficiency and reduce the need for time-consuming adjustments. But what about the work environment? Even if you rationalize your setup operations, you can't expect much improvement if you don't think about the environment around the equipment. You have to ask yourself a few simple questions. Are your workbench and workplace designed for easy use or not? Are you sure that around your equipment you have no potential sources of trouble which could encourage equipment deterioration? Is there anything in your workplace that is unstable, loose or wobbly? Is your lighting adequate or not? It's these kind of little things in your work environment which might well cause problems during setup operations. In other words, you have to improve your work environment at the same time as you improve your operations. Let's look at an example. These are shelves used for storing jigs. Each shelf can be pulled out independently. In this factory, jigs used to be stored on pallets on the floor. However, that storage method brought on various problems, particularly concerned with safety. The pallets used up valuable floor space. It was impossible to fix a storage position, and it took time to find the jig required. The first improvement was to put the pallets onto shelves. However, the whole pallet had to be removed by a forklift truck and lowered to the floor before a crane could be used to remove the jig. The situation still wasn't perfect. So a second improvement was implemented. The pallets were replaced by sliding shelves, which can easily be pulled out to give easy access to the crane. The result is increased accessibility, efficiency, and safety. The point is to work on improvements until you create a working environment which works well for you.
What we've seen so far is there's lots of room for improvement in things we've always taken for granted. Every day I ask myself, what is the purpose of this particular work? Is this work really necessary? Isn't there some way of doing it faster and more easily? You probably ask yourself the same things, and if you don't, perhaps you should. You see, improvements in setup losses can only start when operators get down to taking a good, hard look at all the setup operations they work on. And remember our ultimate aim: 0 setup losses.